Hello, hello, hello. Do you want, can you verify that? Oh, you can hear it on there. Great. That was what I wanted to check. If you can hear it on Zoom.
Hey guys, um, how are you? Doing good? Um, that sounds great. I'm glad you're here. We're gonna go ahead and get started today. Um, my name's Mariah Peterson. I run this meetup, and I have failed. We have not had a meetup for at least 6 months. So I'm super excited to not only have meetups again, but be able to do a hybrid meetup. We have quite a few people here in person. I run four meetups. And of the four meetups, this is the most we've ever had attend and in person since COVID. So I think that's like applause worthy. Good job, guys, for coming out. Like that's awesome. That's an awesome meetup. We want to thank our sponsors for tonight, Amex. I'll give them a thank you. They have some stuff about hiring, some links and stuff. I'm gonna put those in the Forge Slack. If you are not a member of the Forge Utah Slack, we want you to join. You can ask me. I can get you a link. The link is also on the meetup page itself. So that's great. The Forge Utah is a nonprofit. We run meetups. We have an amazingly active Slack group. We have an amazingly active jog board, and we have some of the most experienced software engineers and developers in the state, honestly. Successful people that have sold startups, people that have been doing architecture for years, people who have 30 plus years of software experience, and they live in Utah. So it's a great place to come hang out. Everybody should join. If you don't, just find me. I will get you a link, get you invited, and we want you in there. Other than that, right before I turn the time over to Danny, our speaker, I want to invite everybody to next month's meetup. I am not prepared with a title, but the title is posted on Meetup. Go ahead and RSVP. We'll do that one hybrid again. That's it. If you're joining us virtually on Twitch, we will watch for your questions and we'll be happy to post them to Danny. I know he loves questions. If you're don't have a Twitch account, feel free to post them on Discord or on Forge Slack. And again, I will Forge Slack. So in the Discord, in the live streams channel, and in Forge Slack in the live meetups channel, that is where you'd want to post questions. And that's it. I'll go ahead, turn the time over to you, Danny. Give him another round of applause for giving us talk today.
Thanks, Mariah. I don't really remember how microphones work. It's been a really long time. I think it's been maybe 3 years or 2 years at least since I did an in-person meetup, and I'm so excited to be doing one again. It gets really boring sitting behind a laptop screen, looking at Zoom faces, trying to get your audience to engage. But you guys are stuck with me, and I'm going to get to ask you questions and make you raise your hands, and you guys are going to be so engaged. I'm excited about that. So before I launch into the presentation, I wanted to point out that Mariah is completely right. I love questions because all of the content that I share with you builds on previous knowledge, right? I'm going to be iterating through a lot of different pieces of information that are going to build on things that I talk about earlier in the presentation. So if you get lost early on, let's try to correct for that, and let's try to solve for that by asking a question. Don't be shy, don't be embarrassed. I'm sure other people were also lost or confused by my weird wording, by me talking really quickly, by me just being really excited to talk about all the stuff that I'm talking about today. So please don't hesitate to ask questions if you're in person, and if you're online, then also don't hesitate to ask questions, but I might only get to them at the end of the presentation. We'll see. Okay. Sorry, my phone is really excited to talk to me right now for some reason. Okay, so I'm gonna start off by admitting a very sad truth, which is that I lied to you guys in the name of this presentation and on this title slide. It says that I'm gonna talk about AI observability and how to fix issues with your ML model. Sorry, I'm gonna tell you about how to fix issues with your ML system. Hoodwinked. Now, you might be asking, like, Okay, who cares? Danny, what's the difference? Here's the difference. The ML model, ML code is a tiny part of your machine learning system, right? Your machine learning model is really important. It's the thing that when you put data into it, it outputs a prediction. But in order to get data into it, in order to get that prediction into an application, you need to build an entire system around that ML model. Now, who in the audience recognizes this image? Yeah, nice, Brian. Eric, I know you don't because you haven't read Hidden Technical Debt in Machine Learning System, which was a seminal, phenomenal 2015 paper put out by Google that basically invented the job of machine learning engineers, which is the job of making sure that machine learning models deployed to production can be robust, can be well executed, can basically continue to have uptime and perform well. So when I was here, back in 2018, talking at this exact same conference, I presented a very simplified idea of the machine learning or the data science workflow, which had 3 basic stages. In the first, data scientists were exploring and preparing data. In the second, they were building and validating models. And finally, they were deploying and monitoring. And at the time that I presented this was like a pretty accurate description of what was going on. And what I was really trying to emphasize was the importance of deployment, of the idea that like you need to get your model out of the sandbox and you need to get it serving things. Well, with AWS SageMaker, with Teachable Hub, with Fast AI, with Fast API rather, all of these innovations have made kind of everybody get on board with this idea that you need to be able to deploy your model. But what a lot of people have been missing is also the necessity to monitor your model. So to complement this slide and to kind of insult past tense Danny, I'm pulling another slide these days, this graphic from CD4ML, which is on Martin Fowler's website, that breaks down into more constituent components the process of machine learning. And I think this really helps to contextualize where monitoring and where observability fall into the game here. So we still start off with like model building, we get into model evaluation, experimentation, productionizing, testing, deployment. Like these are starting to become pretty key and pretty well recognized. But what's important is that the last step, monitoring and observability, isn't actually the last step, right? It's the last piece of the puzzle, but it's not the last thing that you do. Because the point of monitoring your model, the point of observing your ML system is so that you can go back and rebuild your model in response to changes in your environment. So I'm going to dive into this topic a little bit more, help to present it with a little bit more framing and context. Before I do that, let's jump into a quick agenda, talking about what I'm going to be talking about today. So I'm going to start off by talking about the fact that you need monitoring for your ML systems. For the last year and a half, I've been giving a presentation that basically just touches on this, just deep dives on why ML systems need ML monitoring. But today I want to go a little bit deeper than that. And I want to talk about the fact that just monitoring a machine learning system isn't enough. And then I'm going to present the topic of observability, share with you in a very self-helpy way the secret to observability, and finally answer the question of what do we do when an ML model degrades? What do we do when a machine learning system stops performing? So let's start off by talking about the fact that we need monitoring. So baseline truth, models degrade in time, right? Models suffer from data drift issues, right? Concept drift, covariate drift, the real world changes, and your model can only model the data that it was trained on and can only model the world that it was trained on. It can't model new data unless you present it with new data. And in addition to data drift issues, there's also data quality issues, right? Do people have ideas of what data quality issues might represent? Yes, Ryan, I see you sitting. Yeah, what's a data quality issue? Yeah, absolutely. The rate of missing data is a great example of data quality issues, right? And these don't really represent something wrong with the machine learning model itself, but rather something wrong with the machine learning system as a whole, really with the data pipeline upstream of the machine learning system. So for this reason, you need to be able to monitor, the data going into your machine learning model. You need to be able to monitor the predictions that it's making. You need to be monitoring your model in order to be able to ensure that it has good uptime, that it still has good performance. Okay, hopefully we're all sold on the importance of ML monitoring. If you're not, don't worry, just look up my name, Danny Leybzon, and ML monitoring, and you'll find like 5 presentations on YouTube talking about the need for ML monitoring. But like, hopefully at this point, we all recognize that ML monitoring allows us to be proactive in solving problems in our machine learning system rather than reactive to when a customer comes to us and, complains. But monitoring is really just the tip of the iceberg. And most of the iceberg under the hood is observability. So monitoring really isn't enough, because all that monitoring can tell you is that something's gone wrong, but it can't tell you what to do when something has gone wrong, right? It helps you detect a problem, but not necessarily solve the problem. So to solve this problem, you need observability. Now, I'm going to draw on some concepts from DevOps and apply them to MLOps. And I think that this is a really powerful strategy and something that I've seen work really well in DevOps, in MLOps, even before MLOps was really like a concept or a world, right? DevOps was developed, over a decade ago at this point as a series of best practices by SREs at Google, at Facebook, at really major companies that have figured out a lot of tricks, a lot of secrets, a lot of best practices to understand how to keep classic software 1.0 applications running. Now, CI/CD is great and lovely when you're dealing with classic software. Obviously, we in this room are machine learning engineers, data scientists, applied scientists. So we're not dealing with like software 1.0 applications. We're dealing with software 2.0. And software 2.0 has a distinct set of problems and also a distinct life cycle, right? The models have a distinct life cycle than classic software applications, but still fundamentally, we can understand there being a cyclical flow, right? This idea that you build and then you test and then you deploy and then you evaluate your machine learning model and the machine learning system around it as a whole. And we can apply a lot of the best practices from DevOps, such as monitoring, such as continuous integration, such as continuous delivery into MLOps. And what I'm going to talk about is one of these concepts from DevOps that proves to be really, really powerful in MLOps, and that is observability. So observability as a concept actually doesn't come from DevOps originally. It comes from control theory, which is tangentially related to computer science, but predates what most of us would qualify as software engineering. So observability in its classic definition is insight into the state of a system by looking at its outputs, right? This makes sense, I think, right? Understanding what's happening within our black box by understanding what's coming out of the black box. Importantly, this requires historical state. It requires, understanding the past tense of what previously has gone into and come out of the black box. And really powerfully, what it enables is postmortems and analysis. It's the key to debugging. Because again, monitoring is useful in that it tells you, I need to debug my application, I need to debug my system. But in order to actually do that debugging, you need to understand what's coming out of the black box. So I'm going to share with you the secret to observability that DevOps has figured out a long, long time ago, which is logging. Classically, the 3 pillars of observability have been defined as metrics, traces, and logs. All 3 of these are just different artifacts that represent the internal state of a system via its outputs, right? Metrics are numerical analyses of this, traces are following the moving components of a system, and logs are unstructured output from an application. So these 3 pillars of observability can be mapped to ML applications as well. So we know that, in software 1.0, there's these 3 pillars. For software 2.0, we need something a little bit different, right? Instead of logging, or in addition to logging the application itself, we actually need to log data. We need to log input data, right? The data that's being fed to the machine learning model. We need to log the output data, which is the inferences or the predictions being made by the machine learning model. And then if we have ground truth, we can also track the performance data. We can log the performance data. Now, what's really powerful about these logs, to reiterate, is that they enable us to understand a system via its outputs. They generate outputs. And if we don't have these outputs, then there's absolutely no way for us to be able to know how our system is doing. Now, this might sound a little bit high-minded, a little bit abstract. I promise we're going to get a little bit more hands-on and a little bit more in the weeds of, okay, how do I actually do this? But before we do, I want to highlight something really important. which is that AI observability, right? The ability to observe a machine learning system fundamentally falls neither perfectly into the category of machine learning operations, nor into the category of data operations, but really sits at the intersection of these two disciplines, right? Because not only do we need to track model metrics, not only do we need to know how our model is doing, we also need to track data of the system as a whole. So AI observability sits at the intersection of data ops and MLOps. So with all of this in mind, with all of this content and information about logging your data, hopefully you've picked up on the fact that I'm trying to sell you something. And what I'm trying to sell you is an open source project called ylogs. So ylogs takes this idea that we should be monitoring, that we should be logging the input data, the output data, and the performance data of a machine learning system and generating logs that are descriptive, lightweight, and mergeable. I'm going to dive into each one of these three attributes really briefly. So descriptive. ylogs profiles are descriptive summaries of the data that are being fed into it, right? They capture stuff like the distribution. So, more than like a mean or a standard deviation, you get to know the histogram of what does my data look like. You get to know stuff like, to Ryan's point, what's the number of missing values or the proportion of missing values? What type of data is being fed into ylogs? All of these things get logged. In addition to being descriptive, they're also lightweight, right? If we think about like the perfect thing to describe data, it would be the data itself. But it's kind of cumbersome to deal with raw data if all that we're trying to do is log it, if all that we're trying to do is get like an artifact out of our data system. So that's why it's important for ylogs to be lightweight as well. They're summaries of data rather than the raw data itself. And ylogs have this third property that's a little bit more unusual, really interesting, and really powerful. And that is that they're mergeable. So I can take one ylogs profile and another ylogs profile, and I can combine them together and get a new profile that's able to describe the two profiles that were fed into it. Now, this is a really useful property of a log because it enables you to act on streaming systems, right? We can have one log and then another log gets fed into it and then another log gets fed into it and they keep getting combined. And these multiple logs can represent arbitrary windows of time. It's also really useful for distributed systems, right? If we're running something like Spark, or if for whatever reason we have a cluster with multiple computers on it, with multiple servers on it, we want to be able to combine the logs from these different servers into a single log to represent the entire system rather than just the individual components. So this is my ylog sales pitch. This is a super cool open source project. I hope you guys go check it out. But now that we've talked about, okay, like how do we do logging? How do we enable observability? The question becomes, that's great, Danny, but like, what do I actually do? Like, how do I actually get into this? And the answer is that there are fundamentally two approaches to what you can do when your system degrades. And one of them is kind of like industry standard, what people are actually doing right now. And the other one is a little bit more aspirational and what we're building towards. And I want to show you both approaches because I think it's important to both understand where we are as well as understand where we're going. So for the first system, we've got a human in the loop, right? We've got a model in production, a whole ML system behind it. It's generating logs, ylogs profiles, and it's getting sent to an observability platform that lets you analyze those logs. And then at some point, that observability platform is like, hey, one of these logs looks different than the previous logs. Maybe I got some like data shift, maybe there's a bunch of missing values, whatever. Something happened and we're sending an alert to a machine learning engineer. Now, Eric, our machine learning engineer, wakes up at 3 a.m. alerted by PagerDuty and Slack that the model is degraded. He hits snooze because machine learning is not that important and he can deal with it at 9 a.m. And what he does is he goes and he analyzes the logs in the AI observability platform. And this analysis hopefully gives him some kind of insight, right? Hopefully the alert was informative. Hopefully it told him like, oh, our performance is degraded by like 30% and our accuracy score has gone way down. And Eric goes like, all right, that's crazy. Why is this happening? Like, what's going on? And Eric figures out, oh, it's because all of a sudden, one of the really key variables is populated with missing values. There's something wrong in an upstream pipeline. Or maybe he realizes, oh, there's data drift. That's okay. I know I can just retrain my machine learning model and that'll update the model so it can work well on newer data. But the important part is that he's gotten this insight, which enables him to take some kind of remediation, right? It enables him to go in and actually update the model in production or in some way remediate the ML system that previously was having issues. So human in the loop is cool, right? It's what we're used to doing. We're used to doing things pretty manually. You analyze the cause of system degradation. Maybe it's a data quality issue. Maybe it's a data drift issue. You take some kind of remediative action based on the issue that you identified, and then you go back to doing whatever it is that machine learning engineers do with their free time. Okay, and then your model degrades and you go through all of this all over again. Now, what if I pitch to you this idea that we as machine learning engineers sit at the intersection of the two most automating fields in the world, right? Software engineering is all about trying to automate things that humans previously had to do manually. Machine learning is all about trying to automate things that humans previously had to do manually. So why on earth are we creating more manual work for ourselves? The answer is that it's hard to automate some of these systems, but that this is where the industry is going, right? This is the bleeding edge of what's happening in MLOps, is automated MLOps. So in this situation, we've got a much more complicated diagram, but fortunately, it's only one diagram. So we've got our data pipeline that's emitting logs to our AI observability platform. It's also sending data to our model in production. Our model in production is also sending logs to the AI observability platform. Okay, great. So we've got a bunch of different logs representing both the data pipeline as well as the model in production. Now, again, something goes wrong. Our model degrades in performance. We've got a crazy number of missing values. We've got data drift, whatever it is. Now, instead of Eric getting woken up at 3 a.m. by a PagerDuty alert on Slack, instead, this AI observability platform sends an informational alert to some kind of intermediary process. And this is where things are still a little bit fuzzy. Now, is that intermediary process, again, like a PagerDuty automated action? Is it Opsgenie? Is it something that people have to build out themselves manually because you need to set up the rules or you need to set up whatever systems you're going to put in place to do this remediation? This is what we're still figuring out. Everything else on here already, like, state of the art, but it's things that exist. This intermediary process and figuring out what best practices around this intermediary processes, this is what's bleeding edge about this. Because what this intermediary process should do is it should take in this informational alert, and then it should decide from this alert without having to loop in Eric, to retrain the model if it detects that there's data drift, to roll back a pipeline if it detects that there's a data quality issue, basically to take some kind of automated action without having to bother a machine learning engineer so that they can focus on whatever it is that machine learning engineers do with their free time. So yet again, I repeat, AI observability, very importantly, sits at the intersection of data ops and ML ops, because in order for this intermediary process to diagnose the problem, it needs to be able to have access to logs, not only from the machine learning model, but from the data pipeline upstream of it, which can be causing problems to the machine learning model itself. So hopefully this brings us back nicely and bookends this idea that instead of focusing only on our machine learning model, what we really want to do is focus on solving problems with our machine learning system. So just to reiterate again very quickly, automated ML ops takes a human out of the process. It automatically triggers a rollback from new pipeline changes when there are data quality issues introduced, or it can retrain a model when there is some kind of model performance degradation. Again, automated ML ops is like partially still aspirational. At Y Labs, we're building out like a very, very early version of this. As far as we know, nobody else is really doing this stuff. We hope the rest of the industry catches up, but this is a really exciting place to be because we fully believe that because DevOps has been able to automate a lot of their processes, we in MLOps are also going to be able to automate a lot of ours. Okay, so now I'm going to take a breath and drink some water and maybe some Gatorade, and I'm going to ask if there are any questions so far. Yes. So the question is, can Danny share proprietary information about what Y Labs is doing? And the answer is not really, but I can tell you that like there are a lot of moving parts, right? Because if we go back to this very oversimplified diagram, like model in production, like what does that mean? Is that like something trained in SageMaker and deployed in SageMaker? Is this something trained in sklearn and then deployed with Fast API? Like, is there a developed CI/CD process around this? Or am I having to like manually trigger every part of this? So because there's so much tool proliferation within MLOps, you know, like training providers, serving providers, and that's not even looking at the data pipeline components, that's just looking at the model in production, because there's so many moving parts, and also because so many different companies have so many different practices or so many different levels of maturity. The answer is like, we haven't come up with like a perfect one size fits all solution. Instead, what we're doing is we're partnering with design partners who come to us and say, hey, like this looks really cool. Can you integrate with, you know, this model training provider and this this deployment provider? And the cool thing is that like most of the time we can, most of the time we're already partners with these people and they have really convenient APIs that we can hit. And especially if these more mature customers come to us and they already have well implemented continuous delivery processes, we can just trigger a continuous delivery process for retraining the model, or I guess a continuous learning process to retrain and then redeploy the model, rather than having to, you know, like manually do all that stuff ourselves. But the answer is like, yeah, this is still pretty greenfield stuff. Yes, Ryan. Are you asking about Y Labs in particular? Yeah. So for the automated MLOps stuff, like this stuff is advanced, right? Like a lot of earlier stage companies, a lot of smaller companies, a lot of less mature machine learning companies don't necessarily need this stuff, right? Like they don't mind having a human come into the loop, having a human analyze, especially if they don't have super big models. I'm using big here to mean like lots of features. If their problems are like pretty easy to solve, then it's pretty easy for a human to go in there and figure out what's wrong and then fix it, right? So what we're seeing, the most interest for this automated MLOps stuff is for people either on the bleeding edge of MLOps, right? Like people who are developing MLOps platforms internally, or people who have just like tons of or super massive models that need to be able to, you know, automatically do this remediation without being able to bring a human into the loop, which is not necessarily characteristic of all of Y Labs' customers, because we have, you know, a broader range of maturity and size and all of these things. But automated MLOps in particular appeals to like one very particular type of customer. Yeah, in the back. Get out. No finance people. It was. I'm gonna call it a comment for the people on Twitch rather than a question. Well, okay. Start with comment and then get to question. So the comment was a very brilliant insight that I have made a very false dichotomy of this idea that there is either a human in the loop process or an automated MLOps process. And as you know, all of us statisticians in the room know, all models are wrong, some models are useful. I think this dichotomy is a useful model, but you're completely correct. It's a wrong model, right? Because automation doesn't happen as on or off. It happens in gradual degrees. There is like a continuity of automation. So the question was like, okay, like what if I'm not ready for like full on automated MLOps? Like what if it's okay for me to have a human in the loop for this stuff? How can I introduce, you know, some of the best practices from automated MLOps into human in the loop? And I would say there's a lot of different ways to go about this. So, you know, one area of automation that I kind of like glossed over was this, this alert, right? So this AI observability platform sends an alert to a machine learning engineer. Why? When? How? Based on what? Okay. So like the idea here is that alerting needs to happen in response to a particular event. We need to have a threshold for that event to be met. Now, how should that threshold be set? Should it be set by, the user coming in and saying, hey, I think that this data should be between 0 and 1, and I'm going to say this for like all of the columns in my model? Should it be looking at historical data? So, over the past 7 days, the data's looked like this. This deviates by, 1 standard deviation from the last 7 days of data. Should it be over a longer time window? Should you take into account seasonality? Should it be based on a baseline profile? Like, there are a lot of hidden automations that are implicit within this alerting mechanism just by itself, right? So that's where a lot of automation can happen. And we do see a lot of like automation related to this alerting mechanism, right? Where like, if you look historically at something like a grade expectations, like now they have a cool like automating setting up your expectations, but like historically you had to manually set your expectations on it. Nowadays, like the majority of machine learning monitoring providers have some amount of automation or some amount of non-configurability to make it easier for people to not have to like manually turn all of the dials. So that's one component. Another component that I would say is like, we can really simplify this diagram if we just like ignore the fact that data ops is key to AI observability, right? If we just say like, okay, if there's a data quality issue, we need a machine learning engineer, a data engineer for that. But if there's a data drift issue, like if we see that the data has changed by, this many standard deviations on the Hellinger distance, then like, okay, just automatically retrain the model. And in your use case in particular, where you're doing forecasting, you're very lucky because you can just do very simple automated retraining of your model because you do have ground truths coming in all the time, right? There's a lot of other systems, a lot of other machine learning and data science problems that don't get solved with like ground truths coming in automatically. Like any kind of computer vision, any kind of like NLP usually requires some amount of human labeling. And what that means is that you need to bring a human into the loop in order to re-implement this model. Does that answer your question? Cool. Thank you for the observation. It was very good. I saw another question. Yes. Yeah. Yeah, that's a really good question. So there's a couple of different approaches to this, right? One of them is online, or as it's getting renamed now by industry for whatever reason, continual learning, where instead of retraining from scratch, you use an algorithm that's able to take in new data and like add it in streaming to a model. So like instead of having to fully retrain your linear regression, you take the new data, you calculate the gradient on it, and then you move along your learning rate towards this model. But this only works for like certain models that are specifically online machine learning, or nowadays called continual machine learning models. Okay, so if you don't have one of those and you have a supermassive model, the question is, how do you manage to get just in time learning or just in time retraining? And the answer is that it's really hard. And probably what you're actually going to do is you're going to set your threshold to be much more sensitive than somebody who has a faster to retrain model, right? Because the statement that you said was like, your model's really big, you're already 3 days too late. Well, what if you just got notified 3 days earlier about this model performance degradation? Now, like setting your automated machine learning system to be too sensitive is a problem too, right? Because then you're going to be retraining your model a lot. And hell, if your model takes 3 days to retrain, like that's probably not the cheapest process to go through. But aside from that, there's not really an option. And the other thing to keep in mind is that with automated MLOps versus human in the loop, like in either situation, you're not going to know ahead of time whether this was a false positive or a true positive on whether to retrain the model. That might have been a little bit confusing. Does that make sense? You got it? Yeah. Yeah. I wish I had like an oracle for you that could like tell you, you really need to retrain your model now. But unfortunately, we've got the data in front of us and the models that we can use to figure out the data. Yeah. Yeah, that's a great question. So maybe a fourth property that I should put on here, if it wasn't for the fact that I fetishize the number 3, is extensible. Because YLogs is extensible in that it allows you to define custom metrics and decide which metrics get associated with your data. So let's like be way more specific about this. So I talked about the idea that you can get a distribution, right? And when I said that, the first thing that came to my head, probably the first thing that came to your guys' head, is some kind of continuous distribution, right? Probably some people thought of bell curves, some people thought of like exponential or power law distributions, but I think most people think about a continuous distribution. But like, what does that mean for image data? Like, what is a distribution of image data? And the answer is that in order to be able to get a profile, in order to be able to get like a summary of a data set, you need to be able to structure it, right? The summaries themselves need to be structured. So what we do when dealing with like image data or text data or other types of unstructured data is we actually find ways to extract structured features out of it. So in the case of images, we take features, we take metadata and features. We take metadata out of the EXIF that might be associated with the image file. So like this might contain the device that the photo was taken with. It might contain like the date that the photo was taken, like this kind of structured data. And then the other thing that we take out is features of the image itself. Usually really fast ones to pull out, like the hue, the saturation, the size, all of these different components. But you know, like for some people, that's not going to be helpful. We have a customer who helps retailers know what's in stock and what's not in stock. And one thing that they have to do is track the number of bounding boxes in an image in order to know how many items are on the shelf. And they want to know when there's an issue because there's lower number of bounding boxes. Well, like we could try to implement our own bounding box algorithm in YLogs, but like honestly, like we're not the smartest data scientists on the planet, and we think that other people probably have better ideas of which algorithm they want to use. So we make YLogs extensible so that other people can add in custom metrics in addition to the metrics that we define for them. Does that answer your question? Cool. I promise I didn't intend this as a YLog sales pitch, but like maybe a little bit, because I've got a little bit more of a sales pitch, which is, oh yeah, go ahead, Eric. Yeah. So yeah. So what you can do, what Eric's referring to is a conversation that he and I had over lunch a couple days ago, not something in the presentation in case somebody thought they were missing something. No, it's super relevant. No, it's very, I just want to like set the context. What Eric's referring to is the fact that it can be useful, just like we have traces, like to go back to the 3 pillars of observability. There's this concept of traces, which effectively allow you to track, you know, as you have a bunch of microservices and as you have stuff moving around within the microservices in an application, you want to know like what has happened to my object that's getting moved around. Okay, what about for data? We want to be able to track the lineage, or there's like a bunch of other fancy words that all basically mean wanting to track how data has changed over time. Over time is the wrong term to use here. Over the pipeline or the life cycle of the data. So one of the cool things that you can do with YLogs is you can track changes in the data throughout the pipeline, right? You can have like your raw data set in your RDBMS, and you can do a YLogs profile against that raw data set. And then you log this profile, and you associate it with like a particular model. And then that data gets moved through like a message bus, like Kafka, and maybe some transformation happens to it in something like Flink. Okay, so now we've got new data that's been transformed in some way. We can log it again and have this new log of data that we can add to the first log of data in order to know, okay, where in this process are data bugs being introduced, like where in this process is there some kind of data anomaly, so that when it's time to go back, whether manually or with automated MLOps, when it's time to go back to the data pipeline or to the machine learning model, you can understand where things went wrong and actually do the postmortem and actually do the debugging that I was talking about earlier. Yeah. So so far I've like avoided talking about Y Labs in particular because I want this to be like a globally useful talk that is not just about the product that my company works on, because I think AI observability is something that like you don't need Y Labs for. Like you can do this with our other products or building out your own tool. But I can talk very specifically about like what this looks like in Y Labs. So within Y Labs, you associate different profiles together via a model, which is maybe a little bit of like not the best terminology to use, but we haven't figured out a better word for it yet. So we've got multiple profiles associated with the same model, and we can open up these profiles and look at that statistical information that we collected from the profile. So we can look at like the distributions, we can look at the number of missing values, we can look at these like key statistical summaries and, you know, dive into them at this point, you know, mostly manually with human in the loop, but hopefully in the future with automated MLOps, in order to understand where were these missing values introduced, like where was the data bug introduced that caused a data quality problem that caused the machine learning model to degrade. So I know this is still very abstract. I don't want to show a product demo at a meetup, so I'm not going to dive into the Y Labs platform, but like basically that's what you should look for in a tool where you want to do data lineage and where you want to be able to look at data change over the course of a pipeline in order to be able to debug it. When your business tells you that there's a problem. No, I mean, I wish there was a better answer, but like, honestly, like there's no magic bullet to this stuff, right? One of the ways that I think about it is similar to, did you guys all have to figure out like what to set K equal when you were doing when you were doing K-means clustering? Like you do K-means clustering and you're like, okay, I know that there's some number of clusters in this data. What should I set my K equal to? And there's some like really weird mathematical techniques based on the eigenvectors of the matrix in order to figure out what the like optimal point along the curve is. And like you can kind of do something like that with data with ML monitoring, where you say like, okay, this is kind of looks like an inflection point, but at the time that you're like that you see an inflection point, you're already past it. So it's probably too late at that point. So what I would say your best option is really to define like some, I'm not going to say arbitrary, some well thought through and human defined criteria based on what your business priorities are, like what the KPIs or whatever these business metrics are. Yeah. Nice. So Joe Reese is like a very dear friend of mine, and I was deeply, deeply concerned that he was going to be trolling me. What are some worst practices? I don't want to talk badly about other people in this industry, but I think that one conclusion that I came to is that you need logging. That like logging is pivotal to monitoring and observability. And I don't think that logging by itself equals observability, because you need to be able to do something with these logs in order to know that something is wrong. But like you do need to be able to look at the historical state of a system. And the best way to do that is logging. And what I see a lot of people doing is instead of like dealing with logs, they either sample their data, which is bad for like a whole lot of reasons that I can dive into, or you can look up sampling versus profiling on the Y Labs blog. But like basically sampling is like not a great way to get a more lightweight version of a log, or they're dealing with like whole data sets, which I guess is okay if you've got like really small models that aren't dealing with a ton of data. But like in the world of big data, in the world where models, you know, maybe have thousands of features, or even if they only have hundreds or dozens of features, but probably, you know, millions of rows, dealing with raw data is kind of an insane thing to do, because you're constantly having to move it around, to process it, to store it, doing all of these like computationally very like fundamentally expensive things. So to me, like it's absolutely an MLOps observability and monitoring worst practice to not do logging. I feel very hesitant saying this because like a lot of people are doing this worst practice, and like you can get away with doing this worst practice because a lot of people do it, but I still think it's a bad idea. Eh, yeah, is that a thumbs up from Joe? All right, okay, good. Yeah. Yeah, great question. That's I would say like online learning, or again, as it's now being referred to for some reason, continual learning is like pretty cutting edge. I don't know of any companies that I'm positive are currently doing. I mean, I'm sure like Google and like I'm sure some of the FANG companies are doing it, but like I can't point to a particular model that's solving a particular problem and say I know that this model is implemented with online learning. What's cool about it though is like you can implement a lot of really classic models with online learning. Like you can do linear regressions with online learning. You can also do like random forests with online learning. And I think there's like a streaming version of gradient boosted trees at this point. So like you could re-implement a lot of this stuff with online learning, but like they're definitely not industry standard. And I think a lot of the reason for this is that streaming is still not industry standard on the data engineering side, right? Like Kafka, Kinesis, PubSub, like these are all getting more and more popular, and they're definitely getting more talked about. But like I used to work in ETL, like I used to work in the like classic data engineering space, and like yeah, streaming is still not as big in industry as it's talked about. And like, of course, we see the direction. The direction is towards streaming, but I wouldn't say that it's like today everything is happening in streaming. So today it's not possible to do a lot of stuff online or continuously. Yeah. So the question was, does streaming only address data drift? So the way that I would correct that statement would be continual learning is a way to address data drift because it automatically incorporates new data into your model without having to manually or automatically retrain your model, right? Because the data just gets added into your model and the model learns on the new data. Yeah, that doesn't solve for data quality issues. That's right. It doesn't solve for data quality issues, but it solves pretty convincingly for data drift issues. Yeah. Yeah, you're definitely like introducing a lot of new problems by trying to solve this problem with continual learning, because now you have to start like versioning your model so that you can roll it back to like take into account this data drift issue, which like if you notice the data drift issue late because you're not monitoring your model, like, oh, you're gonna have to roll it back really far. Yeah, so there's a lot of like new components that you need to introduce to the system, which like probably are good components to have, but like I wouldn't say that online learning is like a simple solution to the problem of data drift. I would say it is the more complicated solution. The simple solution is just monitor your model and then retrain it just in time when something goes wrong. Yeah. Yeah, great question. I love that question. I literally spent an hour talking about this question on a podcast like 3 weeks ago, because the answer is like, even this is too late to start logging, right? Like this starts with model building. Honestly, like I think Martin Fowler kind of like fouled or like woofed on this one, because there's a lot more to the process of machine learning than model building, right? Like there's data cleaning, there's data preparation, there's all of these things. Honestly, like you need to start all throughout your data pipeline, right? Because you need to be able to go back to, if I can scroll through an entire presentation, you need to be able to go back to the data pipeline and identify where in the data pipeline the logging has been happening, or like where the problem was introduced, which means being able to log it there. I would say like at the very minimum, you should log your training data, which I use broadly to mean like your sandbox data, like your training as well as your testing and validation data, because that allows you to establish a baseline against which you can compare all of your later data. And in this way, you can at least take into account data drift. But if you're not also logging much earlier in the process, like if you're not also logging all throughout your data pipeline, then when a data quality issue gets introduced, you're not going to be able to resolve it because you're not going to know where the problem happened, where it got started. Does that answer your question? So first of all, I need to drink some water. And second of all, I don't think I totally understand. Can you ask one more time? That's a great question. Okay, I think I understand better now. So I would say that like data logs in the way that I'm using them don't address the problem that you're thinking of, because the problem that you're thinking of is actually not logs in the way that like data logs is being used here, but actually model metadata, right? It's like the weights, the model type, the parameters, like all of these different components. What you really want in this situation is like a model versioning system. And there's a bunch of really good ones of these out there, right? Like Comet or like MLflow, weights and biases. Like there's all of these different solutions that allow you to track your model metadata so that you can do your experiment tracking. And then once you're in production, you can compare multiple types of models against each other. Whereas this is like really focused on data logging, if that distinction makes sense. So is my friends over at ZenML, which is like a poppin' German startup in MLOps. I think I'm like the second speaker on this podcast, so it should be pretty easy to find me. Okay. Yeah, I'm happy to do that. The first speaker was Noah Gift, if you guys are familiar with him. He wrote a really good book on MLOps. So it was really nice to follow him up. Yes, Ryan. Yeah. Yeah. And they're also talking about their YLogs integration. So yeah. Yeah. Yeah, great question. So it's do you have different considerations when thinking about a batch model versus thinking about like what I would call a streaming model or like an online model, right? Where you have like a REST service that gets called, and is that a fair distinction? Yeah. 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 So I would say yes. And I would highlight again the importance of the mergeability feature in YLogs. And like this is one of the things that makes YLogs super cool, is that you can either generate a profile on your entire batch data set, and in this way get, you know, just a single profile that represents the entire batch data set. Or if you have a streaming system like a REST API, you can be continuously profiling new data as it's coming in and then merging those new profiles with the existing profiles. Now, you know, that's like me being really excited about YLogs. To answer Eric's question, like more broadly, what are the considerations for streaming versus batch? I think one of the things that people intuitively feel is that when a system is fast, it also needs to be monitored fast. Like if a system is streaming data, then you need to be able to know right away if something's going wrong with it. And I actually don't think that this is true for human in the loop MLOps, because I think ultimately, like the thing that's going to be slowing down a system, whether it's a streaming system or a batch system, isn't going to be the engineering components of it. It's going to be the human components of it. This is a little bit abstract and vague. Let me talk about this more concretely. So if we're like, we're imagining we're monitoring two models, right? One of them is a batch model. The other one's a streaming model. The batch model at the end of every day gives you 1,000 predictions. The streaming model over the course of a day gives you 1,000 predictions. Now, there's some kind of data drift that gets introduced. Okay. This becomes apparent over the course of a day if you're like continuously monitoring your streaming model. It becomes apparent at the end of the day if you're looking at your batch model. What are you going to do differently in response to maybe having caught this at 4 p.m. instead of 5 p.m. I don't know, like either way, you're probably going to be putting it off until tomorrow anyway, because a lot of this like manual getting insight work isn't something that happens instantaneously, right? Like when there's been some kind of problem, it's going to take some time to figure out what the problem is. So in the situation that you have human in the loop machine learning, I actually don't think that there is a huge difference between monitoring streaming models and monitoring batch models. Now, I think there is like a fair argument to be made that with automated MLOps, this could theoretically be different, right? That like maybe it's worth it to have a system respond instantaneously instead of the next day. I would say that like the majority of the time, machine learning, even when it's mission critical, when there is like a degradation in its performance, usually like that's not going to cause the end of your business from a single day. Like it's probably going to be bad for your business if it's like really mission critical, but it's probably not going to be like the end of the world. There are of course exceptions, and I'm talking like very, very broadly, but in the majority of situations, it's okay to wait a day. So I would say that like the majority of the time, batch versus streaming doesn't have like that many differences in the way that that you should monitor. That answers the question, Eric. Cheers. Okay, I like briefly flashed this slide, and now I'm really excited to show it to you guys again. So I don't know about you, but I started running low on t-shirts this year, and I was like, how does this happen? Like, what's going on? Turns out when you're not going to conferences all the time, you don't get a lot of swag because for whatever reason, companies are not handing out a lot of swag these days. Well, I am here to be able to give you swag. And if you do these 3 simple things, I will give you, unfortunately, not a t-shirt, but this very attractive stress ball that's pictured here on the screen. So this stress ball is meant to be squeezed whenever you're facing some kind of problem with your machine learning system. Whenever you get really frustrated that your model's not performing well or whatever it might be. Mariah is giving me a very intense look. So Mariah would destroy this stress ball in like an instant, but hopefully people get some good use out of it. And because I am local to Salt Lake this winter, I have a very, very special offer, which is that I will literally drive this stress ball to your house and either social distance, drop it off on your front door, or give you a handshake and talk about your MLOps problems with you, maybe over like tea or like some kind of therapy session. Now, the requirement for getting this like free therapy session and the stress ball is that you have to go to bit.ly/ylogs and give a star to the ylogs project. I know it takes a lot out of you to start a GitHub project, but I promise it's worth it for these stress balls. To join our community Slack, where we're starting to develop a community of people who are talking and thinking about a lot of the problems that I am addressing here. It's definitely, you know, not the MLOps community that Demetrius hosts, but we've got a few hundred people in there already. And the only way to make a community viable is to get people into it. So hopefully if you go to bit.ly/ylogs Slack and sign up for us there, you'll get some value out of the Slack as well. And then unfortunately, I do need to get some personal information from you, namely, where do you live, so that I can drop off this swag for you. I promise I'm not going to send this to anybody or do anything other than drop off swag at your house, or mail it to you if you don't want to drop it off also. So I'm going to move on to the next slide. Hopefully people have already gone and starred and joined the Slack and told me their addresses. I think I answered all of the questions that people had already, but if people have more questions, I'm happy to answer them in this group setting. If that feels scary to you, I'm happy to answer them live here while we hang out and eat pizza. Or if even that feels scary to you, I'm happy to answer them in our community Slack. One more good reason to join our community Slack, or just reach out to me on LinkedIn. I'm Danny Leybzon, or my email, danny@ylabs.ai. Cool. Any other questions from anybody in the room? And then we can clap. Ryan, is that half the question? Yeah. Thanks, guys.
I didn't put a link. I'll send a link to. Oh, okay. I just wanted to say we're hiring at MX. We're here tonight, and we'd love to host more meetups. So if you have a meetup in the area and you're here in person or you're on Twitch and you're looking for a place to host it, reach out to Mariah and she'll get in touch with us. We're happy to buy pizza and open our office to you guys. Right now we are hiring. We have some really great data enhancement tool positions open. We have some data ops positions open to help build our streaming pipelines. We have some data scientists, senior data scientist roles open on the product side, and product and analysts. So across the board, across the spectrum, multiple disciplines, we're hiring for our data team. So that's a shout out. And then the last thing was, we have maybe 20 something people here in person, and we have 14 large pizzas on the counter. So do me a favor and take a pizza home with you. Take it home. That's it. To Danny.